When a VAMAS file is loaded, the data appear logically as a set of rectangles that are labelled in the right hand side. And you can display these by double clicking, or you can display these by selecting and then applying a button that will generate a scroll list in the left hand side. And the idea is that each one of these entries in the scroll list corresponds to one of these entries in the right hand side. So there's the oxygen 1s and there's the oxygen 1s here. If you click and give focus to this oxygen 1s, you can see that it becomes focused here with a red box around the oxygen. And I can also slide up this list and make other selections based on the list in the left hand side. I'm holding the control key down to click in one of these tiles and it adds to the selection over here. So I could select 4 of these by a combination of clicks in the right hand side and the left hand side, holding down the control key to add to the selection. And then I could just display a limited list of just the 4 that you see now. And if I go to the tile format dialog window, I can see all 4 in one page. So the order that these appeared in this page was based on my selection order over here. So if I wanted to have, instead of oxygen here, I wanted the iron, I could select that first, then the molybdenum, then the carbon, then the oxygen. So it'll go iron, molybdenum, carbon, oxygen, and when I press this button here, you can see iron, molybdenum, carbon, oxygen. There is another button, however, that says order by energy. And when I press that button, rather than having the order of selection, it's now ordered by the binding energy. And you can see this in terms of the sequence of binding energies here. And the way it's organized these according to these binding energies is actually based on the element transition fields here that are used to extract information from the element library. So the element library, when you click here, will display iron information, and it's giving you relative sensitivity factors. And in order to pull in the right RSFs for a given spectrum, you need to have the element transition field match between the element library and these spectra. So it's important to see that they are in the right order, and the element library can order them so that you then know that the right RSFs will be brought in. So the question is, what happens if you do not have a matching element library entry? So what I'll do is I will demonstrate this by selecting 4 here, and we have 4 that, well, actually let me select them in the order that they were here, so you can see sodium, nickel 2p, nickel OJ, and the oxygen 1s. If I press this button here where it orders by energy, you can now see that the OJ has been brought to the front of this list, while the sodium, nickel and oxygen now appear sequentially. This one does not, and the reason it doesn't is because this field here, the element transition field, doesn't match the element library. So when I bring up the element library and I select here, you can see why. That the nickel has been labelled LMM, and this is discretionary, you can choose this. So in this particular set of data, there's a selection where you have LM squared, meaning 2mm. And similarly, you might have, as in this case, you may see that doublets are labelled 1/2 and 3/2. Now other files don't do that. They may have them where you say the manganese 2p1, meaning the 1/2. So what I'll do now is I'll load an element library that uses this alternative way of labeling the OJ and also these doublet pairs. And I've got a library here that's been organized in that way. So when I select this and I load it, and I click here, you can now see that this now matches the element transition field. So when I press the button here, or rather I should have selected these again. That's the order of selection. and that's the order based on the energy. And now each one of these now matches, and you can see that the element library, when I select nickel, you can see that the nickel now displays the names from the element library where it's 2p1 and 2p3 rather than the saying 1/2 and 3/2. So the importance of this is that it gives you a way of checking that the element library is consistent with your data and how the data have been labeled in terms of element transition fields.